Hello all, in this video I'm going to talk about simulation modeling. Now what is simulation? Simulation is nothing but you're trying to duplicate the features, appearance and characteristics of a real system. It is nothing but, say you're going to launch a new product, okay, you're not sure how good it will be and how bad it will be, okay, and you are not sure what would be the fluctuations in stock market. You're just trying to simulate with the current values what would be uh, future simulations, what would be your demand and what just in an imaginative sense. Okay, this gives an idea. Okay, what would be our rate if it goes bad in different scenarios. Okay, simulation is just to imitate a real world situation mathematically and draw conclusions from the results. And I'll show you how to do that in Excel. It's very simple. Yeah, what is the process of simulation? So anywhere before starting you must be clear with the problem. What is the problem and what are your important variables, okay, that you have to define. Then you have to construct a simulation model. Then you have to specify what values to what values. I'll explain you that in detail directly in Excel. Okay, then we conduct the simulation. We'll see different scenarios, okay, and finally we draw conclusions. What would be the final conclusions, okay, and then finally we have to examine the results and select the best alternative. So it's mostly people use this for a new product launch. That is a major application of it. Yes, in this simulation, the best method, one of the best method is Monte Carlo simulation. The basic idea of Carlo simulation is to randomly generate the values for the unknown elements. Okay, and in Excel sheet we have a random, say a formula function called random function, where we can generate random values. And these are the three steps to perform Monte Carlo simulation. First, we have to check what is the probability distribution of each variable. What is the distribution of each variable which we are going to simulate? And using random numbers, I'll tell you what is random numbers. Random numbers values from varies from 0 to 1, and it's nothing but a probability. It based on the probability distribution. That I'll explain you what it is directly in the Excel sheet. And then we have to try to reiterate the process and see, we have to reiterate the things, and then finally we have to come with some conclusions. These are the steps. Okay, step one, we have to say, as I said, project activity, product demand, say stock price. These all future is completely unpredictable. So using simulation, we'll get an idea whether to go for this product or not, whether to go for this investment or not, or say there would be a deadline in project. So we just try to simulate with different constraints and see whether we could able to complete or achieve the project on date. Okay, so let us take this example of Joseph Automobile, right? We have to take the example of Joseph Automobile. Here is the Joseph Automobile. So what it says, over the past 60 months, the data has shown that uh, the data is here. The past 60 months, the data has shown some of the data. I mean, past 60 months demand data is shown. Okay, and the selling price he wants to launch is 74 per unit, and fixed cost is equal to 2000. Okay, that is the cost of fixed cost, and the demand is what we have to check it here. So past 60 months demand, okay, 60 months here up to 1 to 60. 300 demand came 3 times, 320 demand came at 6 times, and 340 demand appeared for 12. I mean the frequency of these demand, so it has varied from 300 to 400 these many times in the past 60 months. So how do you calculate the probability? It's very simple. Just we have to take the overall frequency, overall observation. Total observation is 60. So what is the total appearance of 300? I mean total frequency of 300. 300 is 3, so divided by 60. How frequently 320 demand appeared in that table? 320 appeared 6 times, so 6 divided by 60. How many times 340 appeared in this full table? It appeared 12 times, so divided by 60. Then 360 appeared how many times? 18 times. So majorly the variation is from 360 to 380 demand. Okay, So 380, how many times, what is the frequency? 15. So 15 divided by 60, 25 probability. Then what about demand? Demand is 400, which frequently it appeared 6 times. So 6 divided by 60 will give you, this is the probability table. Now for this graph, you have to draw the probability distribution curve. That is the second step. Second step is just to check what is the probability distribution. Simulate values from probability distribution. So the moment we draw, this is the probability what we got, right? So what is this distribution? Now what is mean by distribution? There are different distributions. Okay, continuous uniform distribution, discrete uniform distribution, normal distribution. You all know what is normal distribution. Exponential distribution, binomial distribution, discrete general distributions with two outcomes, and discrete general distributions with more than two outcomes, right? In this problem, what type of distribution is this? First of all, what data is this? This is nothing but this is a discrete with more than two outcomes, because we cannot say exact outcome because it varies from 300 to 400. Whether and the distribution is completely discrete in general. Okay, it is not in uniform. It is discrete in general. Okay, so we have to use which formula out of all this form? We have got the distribution which is discrete general distribution. So formula to perform discrete general distribution is lookup rand function comma range 1 range. This I'll explain you in Excel in very step by step manner, so you need not worry. So just sit back, relax. I'll show you how to do it in Excel. Okay, so you can follow me step by step along with this video, right? Yes, we were talking about simulation, right? Yes, we want to perform this in Excel. So what I did is I just copied this table in Excel, right? This demand, and we had generated the distribution for this, right? Insert chart. The distribution, we got it like this, somewhat like this, right? This is this comes under discrete distribution. Discrete distribution which has general discrete distribution which has more than two outcomes. Okay, so the minimum value is 300 and the maximum is 400. That's the demand property, right? So once we have decided that, now we know the formula. The formula is nothing but this one. Just copy this in Excel. Okay, just copy paste for your reference. Copy and keep it pasted here. Okay, so whenever you have a doubt in formula, you can just go through this. Now coming to the question, what was the case study question? The question is, the selling price it wanted to sell is at rupees 74 per unit. So how do I write that? I write Joseph company, right? Joseph Private Limited. Joseph Private Limited had selling price. He wanted to sell it for how many rupees? Selling price per unit. Selling price per unit is rupees 74 as per his format, right? Then what is the other details? Fixed cost is 2000, right? Fixed cost, I am writing in short. Fixed cost is 2000, right? So fixed cost is 2000. Then we have we have other details like, yes, this was the data. So we saw that selling price was 74, right? Fixed cost was 2000. Material cost per unit is 28. This is per unit, sorry, this is per unit. And labor cost per unit is 40. The demand is what we have to simulate. Okay. In normal, say if they have given a demand, say 300, right? So you'll write 300 here, but it is not sure, right? It keeps on varying based on the probability. So we have to simulate that. Now, here profit, how you will calculate profit here? It's very simple. You have to use the formula D, right? Demand into selling price minus all this minus this close, then again you delete the fixed cost, right? Once we give some values here of demand, right, it will come, right? For example, I give 200, so it shows 800 loss. So 300 shows 200 loss. So that is how it goes, right? So here our objective is not that one. Our objective is we have to find out what is the demand rate. Okay, this is our question. That is what we have to simulate, right? How do we simulate that? It's very simple. Using this formula, first let us paste this here. 1 minute. Yes, first we have to calculate the cumulative probability. Cumulative probability. How do we calculate cumulative probability? It's very simple. Just we have to keep on accumulate this, right? So this plus this. So just drag it down. So it will calculate the cumulative probability. Now one more thing we have to calculate is we have to calculate the internal. Yes, we have to calculate the inner lower limit. How do we calculate? This is the demand, right? This is the probability which we got, and we saw that there was a discrete distribution. Okay, discrete distribution, and this is the cumulative value, and we have to take a lower limit of this. Lower limit. What is the lower limit? This cumulative will be the upper limit. The lower limit will be 0 for the first one. It varies from 0 to 5. Then lower limit for the second demand is the previous one. So just to drag it down, this is the lower limit, this is the upper limit. Cumulative is the one which is the upper limit, right? So once you get this, now look at this formula. So why we are using this formula? Because we got this distribution as a discrete distribution. Now come to the profit cell. Okay, what you have to set the demand. Let us take the new cell. Okay, the simulated demand. Okay, simulated demand. First random values. Okay, random numbers, right? Random numbers. How do we generate random numbers? Very simple. There is a formula called RAND. Okay, rand close open bracket close bracket. I said it varies from 0 to 1. Okay, now what you have to do, you have to simulate the demand. How do you simulate the demand? Very simple. This is the formula. Okay, is equal to lookup function. Right? We have to use that lookup function, right? Then it has asked rand between. We have already done here rand between. That is our rand between value, comma. What is the range 1? Range 1 means what it has written here, you can see in this book. What is written in range 1 is cell range that containing lower limit of random numbers, range 2 containing the variable values. Okay, so rand function is what we got here. The cell range 1 is nothing but the lower limit. Here it is the lower limit. Select that cell, then the next one, comma. The range 2 means what? Cell range containing the variable values. We are actually simulating the demand. So that is our variable values. Then enter it. And now after doing this, what you can do, you can just keep on, control. You can keep on pressing F9. This is the simulated value. Now, how do we calculate profit? This everything will be same except the demand. Demand you have to take now this simulated demand. Okay. Now keep on pressing F9. You get this is the simulation values. Okay. This is the simulated demand. Now, what you can do with this simulation? You can generate, you can reiterate iteration. You can generate the iteration of about 10,000. Okay, in order to see whether what would be the probability of making loss or profit. Okay, so first what we did, we took all these details. Only demand was in a different form, so we did the probability calculation. Then we saw the distribution. What was the distribution you saw? Insert chart. This was the distribution. So this is called discrete distribution. So the moment you have the data in discrete distribution, you have to use the formula lookup rand. In lookup rand, the formula requires lower limit and the range values. So that's why you have to calculate the lower limit. How I showed you how to calculate that lower limit, right? Then you have to come to the formula, lookup formula. Lookup rand is nothing but random function. We are using random function, comma range 1 means what? Cell range containing lower limit, right? Cell range containing lower limit, comma cell range containing the values. We are actually simulating the demand. So that is this what. Okay, so now once you have done this, you can generate a 10,000 iteration. Let us do that. Now, how do we do that 10,000 iteration? It's very simple. Our ultimate motive is to see what is the profit, what we are going to make the profit with the simulated demand. Okay, so once again, I am taking the profit cell here. This is my profit cell, right? I'm just taking that as a reference. Here, a formula is correct. Demand into selling price minus all the cost minus fixed cost. Right, that is the profit, right? Now how do I generate 10,000 iteration? Very simple. Press 1 here, then click on this corner, right click, okay, not left click, right click, drag it down and drag it up. The moment you leave the mouse, you can see the series, right? Click on the series, you will get this dialog box. So step 1 value is 1 and stop value is 10,000. It is always recommended to go for 10,000 iterations. Okay, and this we are going to perform in columns. So select columns and then click OK. The moment you click OK, you can see there is a 10,000 numbers generated. Now I have to simulate this for 10,000 times. How do I do that? Very simple. Just drag this here, right? Control shift down, back. You remember in the first chapter we did what if analysis. Go to what if analysis, data table. Since these all simulation values are in columns, so select the columns, select the empty cell, then click OK. And here it is. Here it is, this simulated value. Just keep on pressing F9. You get different simulations. Right, you got it. 10,000 simulation has been generated. So if you want to change, keep on generating it, keep on pressing F9. You can see the different values. Now let us come to the actual part. What you have to do, what is the purpose? The major purpose is profit, right? The major purpose is profit. The question mark is that the problem which we are dealing with is what if Joseph Private Limited goes with this price for this fluctuating demand from 300 to 400, what is the probability that he'll make a profit or loss using simulation method, right? Now the moment you generate 10,000 simulation, you can start by doing the maximum one first. You can start the maximum. What is the formula for maximum? Very simple, is equal to max, right? Max of from here to down, control shift back and control enter. So maximum is 400. What is the minimum? what is the minimum. Just click here, minimum function, click here, control shift down, control shift back, close the bracket. Now the maximum is 400 and the minimum is 200. That is your profit making. Control F9, F9, keep on pressing F9, right? The maximum minimum value won't change because it has taken that range. Okay, then count, take the count value. Okay, count value is nothing but just use the count function, count, count. Just control shift down, control shift up, control shift down, control backspace, sorry, right? Close it. So the exact count is 10,000, right? Now what is the probability that he'll make loss or profit? What is the probability that Joseph Private Limited will have no profit, no loss? Let's say will have less than or equal to 0. Will have profit of less than or equal to 0. Very simple. What function we have to use to identify that? Just press is equal to count IFS function. Count IFS function. Criteria. What is the criteria? Criteria range is this range. Control shift down, control shift up, then comma. The criteria is what is the probability that it will have a value of less than or equal to 0. Okay, that's it. Just close the bracket and enter. Since we are doing percentage calculation, we have to divide it by count, right? Count is nothing but 10,000. Yes. So what is the probability of making loss here? I mean less than 0, 15%. So what decision you would take, whether you would go for this price or this kind of demand or not? Will you go or not? Count IFS. If these values are less than or equal to 0, what is the percentage? The percentage is 15%. What is the percentage that 0 greater than 0? 84%, right? You can just keep on simulating it. So there is a always high chance of making profit than making loss if you go with this price, with this selling price for these cost. Okay, so that is the overall objective of this simulation, right? This is just a very small example. We can deal with many complex problems that also will help, right? That's all about Monte Carlo simulation.